Okay, now that we're hopefully unmuted, we'll start over with tonight's presentation. Welcome to tonight's winter web series on weather and aviation, brought to you by the National Weather Service Forecast Office in Goodland, Kansas. I'm Scott Lockhart, one of the lead meteorologists and the aviation program leader here at the Forecast Office. Hopefully you've had an opportunity to catch our prior Facebook Live Fall web series presentations on reporting winter weather and travel and winter weather safety. This presentation will be recorded and posted on our social media sites like Facebook, Twitter, and YouTube, along with our prior web series topics. Links to those sites will be posted at the end of this presentation. Here are the topics I'll be covering tonight. I'll briefly go over how I got into doing what I do here at the Forecast Office in Goodland. I'll give an overview of a couple big initiatives being undertaken by the FAA and National Weather Service that are changing the face of aviation operations across the United States. I'll explain the services of each of the 5 different aviation operational units within the National Weather Service. And after that, I'll go into more detail about our role in aviation we play here at the National Weather Service office in Goodland. And finally, I'll share some aviation resources and wrap up the presentation by answering any questions you may have. Do you love acronyms? One of the standard jokes we hear is that the acronym NOAA, N-O-A-A, should stand for the National Organization for the Advancement of Acronyms. It's hard for anyone to talk about NOAA, the National Weather Service, or the FAA, or anything related to aviation without using a slew of sometimes confusing acronyms that only pilots or government employees seem to understand. While I won't be able to avoid using numerous acronyms over the next several minutes, I'll do my best to explain them as I use them. How did I get here? Many folks in the National Weather Service can point to a single moment or event like a severe storm they experienced or a class they took when they knew they wanted to become a meteorologist. For me, it was a slower progression. Growing up in Colorado, I had a lot of outdoor interests, including ones that pertain to the atmosphere, like building and flying model rockets, kites, and radio-controlled aircraft. Those interests led me to pursue a degree in aerospace engineering that then transitioned to aviation technology based on a recommendation I got from one of my former 4-H project leaders. I ended up getting all my pilot and instructor certificates and ratings with the intent of becoming a professional pilot. However, in the back of my mind, I always felt like the single basic meteorology class I had during my pilot training wasn't enough to fully understand the weather I was going to be flying in. So while I was waiting to find a flight instructor job, I enrolled in the meteorology program at the University of Northern Colorado. Halfway into that first semester, I got a flight instructor job in Lubbock, Texas, teaching mostly students from the United Kingdom. That job lasted less than a year. I got married, and I needed to find a career field that was more stable than aviation at the time. So I went back to UNC, finished my meteorology degree, and got hired by the National Weather Service after graduation in January of 1994. So my career with the Weather Service has taken me from Sheridan, Wyoming, where I got started as an intern, to Glasgow, Montana, where I transitioned from a general forecaster to a senior forecaster as the office spun up operations over northeast Montana. I made my way to Goodland, Kansas, where I've been a lead forecaster for a little over 23 years now. So my recommendation to younger folks with an interest in math and science is to always keep pursuing your interests and be willing to follow some of those opportunities that present themselves that may not follow an obvious path. And with that background information out of the way, let's take a look at how the National Weather Service fits within the larger aviation community across the United States. Right now, there are 2 big initiatives underway at the Federal Aviation Administration and National Weather Service. The FAA is in the middle of their Next Gen initiative, which stands for the Next Generation Air Transportation System, and the National Weather Service is in the middle of their Weather Ready Nation initiative. So what is Next Gen? That is the FAA-led modernization of America's air transportation system to make flying even safer, more efficient, and more predictable. It consists of a series of interlinked programs, systems, policies, procedures, technologies that are being implemented to dramatically improve the operation of the national airspace system, while also reducing the environmental impact of aviation. There are numerous different aspects of Next Gen. This infographic shows the complex arrangement of just the weather information management portion of Next Gen that ingests and processes weather data and makes it available to the aviation community in the format they require. The most important thing for us to notice here in this infographic is that NOAA and the National Weather Service have a role in this arrangement. And That little area is right there. That's where NOAA's comes into the picture there. What is the Weather Ready Nation? This is a national initiative where the National Weather Service is dedicated to help building communities that are ready, responsive, and resilient in the face of increasing vulnerability to extreme weather and water events. Aviation is one of those communities. The National Weather Service is incorporating new science and technologies and is transforming its operations to help America respond by providing forecast information in ways that better support emergency managers, first responders, government officials, businesses, and the public to make fast, smart decisions to save lives and property and enhance livelihoods. Now we'll take a look at the 5 aviation operational units within the National Weather Service. Those are the Aviation Weather Center, the Alaska Aviation Weather Unit, the Honolulu Forecast Office, the Center Weather Service Units, and the Weather Forecast Offices. The Aviation Weather Center is located near the Kansas City International Airport and shares a building with the National Weather Service Training Center, Central Region Headquarters, the Operations Proving Ground, Climate Services Monitoring Division, and the National Geodetic Survey. The AWC is one of 9 national centers under the National Centers for Environmental Prediction within NOAA. The purpose of the Aviation Weather Center is to deliver consistent, timely, and accurate weather information for the world airspace system. Aviation Weather Center forecasters coordinate regularly with CWSUs, WFOs, and advise the FAA planners on weather that may affect safe and efficient use of the national airspace system. The AWC does this in 3 primary ways. First, the National Aviation Meteorologists are located at the FAA Command Center, and they provide impact-based decision support services and deliver collaborative forecasts to support strategic planning in the movement of aircraft across the United States. Second, domestic and international operations issue aviation warnings known as SIGMETs, which stands for Significant Meteorological Information, and concern the safety of all aircraft. They issue aviation advisories known as AirMets, which stands for Airmen's Meteorological Information, which may be hazardous to mainly light aircraft. They prepare domestic and international forecasts for turbulence, icing, sealing, and visibility across the lower 48 states and adjacent coastal waters, the Gulf of Mexico, parts of the Atlantic Ocean, and high-level weather charts with global coverage. And third, the Aviation Support Branch develops the latest tools and techniques for aviation forecasting, is responsible for data flow, and they also maintain the aviationweather.gov website. Here's a closer look at the aviationweather.gov website maintained by the Aviation Weather Center Aviation Support Branch. If you're a pilot, the information presented here doesn't take the place of a regulatory compliant pre-flight briefing, but it is a wonderful tool for pilots and air crews to gather information for flight planning and weather familiarization purposes. This website is worthy of a webinar all by itself, and the link to this site will be given at the end of this presentation. The Alaska Aviation Weather Unit is the primary meteorological watch office for 2.4 million square miles of Alaska airspace from the North Pole to the North Pacific. The AAWU is responsible for AirMets, area forecasts, SIGMETs for 245 zones across a diverse climate and topographic region. Their forecasters also produce icing, turbulence, thunderstorm, and flight category graphics. This office is co-located with the National Weather Service Forecast Office in Anchorage, the Alaska Regional Operations Center, and the Alaska and Pacific River Forecast Center. The AAWU forecasters collaborate with the Anchorage Center Weather Service Unit, the Aviation Weather Center, and also with international forecast offices in Russia. The AAW also doubles as the Anchorage Volcanic Ash Advisory Center, which is responsible for detecting and tracking volcanic ash from more than 50 active volcanoes in Alaska, while also monitoring volcanoes on the Kamchatka Peninsula in Russia for possible downstream impacts they may have on the Anchorage Flight Information Region. The Honolulu Forecast Office is one of the 3 meteorological watch offices with aviation forecast responsibilities across the Pacific. The Honolulu Forecast Office issues the normal Forecast Office related products that include aviation forecast discussions and 11 terminal forecasts, with 2 of the Taft forecasts outside of the Hawaiian Islands at Midway and American Samoa. Additionally, they also issue airmets, sigmets, area forecasts, route forecasts, and wind and temperature aloft forecasts that cover their designated area of the Pacific Ocean, which incidentally covers approximately 8 million square miles. The Center Weather Service units were created as a better way for air traffic controllers to receive timely weather information. This followed the 1977 crash of the Southern Airways Flight 242 after it flew into a thunderstorm while en route to Atlanta. The CWSUs place National Weather Service meteorologists in each of the 21 air route traffic control centers, where they monitor the weather and provide specialized tailored forecasts and advisories of thunderstorms, turbulence, icing, and precipitation affecting the national airspace system. Face-to-face, on-the-spot briefings convey a variety of weather information to air traffic controllers and are vital in helping FAA personnel safely and efficiently route traffic. What do we do at the Forecast Office in Goodland? Well, the Forecast Office in Goodland is one of 122 forecast offices located across the United States, Puerto Rico, and Guam. We're staffed 24 hours a day, 7 days a week. In addition to our other duties, we write terminal aerodrome forecasts, TAFs, that incorporate local forecaster expertise for 2 sites, which include McCook, Nebraska, and Goodland, Kansas. Those are only 2 of the more than 700 locations where forecasts are issued for airports across the country. TAFs are issued a minimum of 4 times per day, every 6 hours, and during standard time that corresponds to 5 p.m., 11 p.m., 5 a.m., and 11 a.m. Mountain Time. These forecasts apply to a 24-hour period across an area within 5 statute miles from the center of the airport runways. They are consistently updated to best reflect expected future weather conditions that directly impact aircraft takeoff and landings and airport operations. TAFs include information about wind speed and direction, visibility, present weather, ceilings, and low-level wind shear. And we'll see what one of those forecasts looks like here on the next slide. Here's an example of a TAF recently issued for Goodland, Kansas. TAFs are encoded forecasts that use abbreviations and definitions similar to METAR-coded weather observations. METAR is yet another acronym that roughly translates from French as Aviation Routine Weather Report. So it's an observation, basically. So what is this forecast telling me? So we'll point out a few things here and go through them. So TAF, this is a terminal aerodrome forecast. KGLD, that's for the Goodland site, who is issued the 11th day of the month at 11:20 Zulu time, or UTC time, which corresponds to 4:20 in the morning. It was valid from the 11th to the 12th, from 12Z on the 11th to 12Z on the 12th. And we have wind speeds and direction here. The direction is 250 degrees. So if you were to go around a compass where 0 degrees or 360 degrees at the top, 180 is at the bottom, 250 degrees is roughly westerly. And the 12 there indicates that it's 12 knots. KT stands for knots, which is nautical miles per hour. P6SM, the visibility group here, that means the visibility is greater than 6 miles. And the sky condition, SKC, means the sky is clear. So the next group here is what we call a from group. FM stands for from. And the date on the 11th at 17Z, which is 10 a.m. The wind direction changes slightly. It goes more to the northwest, increases to 12 knots, and we see some gusts up to 20 knots. Visibility is still greater than 6 miles, and the sky is still clear. Then, as of 1Z on the 12th, we change dates as Zulu time here. That would be 6 p.m. Mountain Time. The winds go back to the west and decrease in speed slightly. Visibilities are still greater than 6 miles, and we see a few clouds at 25,000 feet. So that right there is a very simple TAF written for the Goodland site. Some really simple information there and some basic decoding of that TAF. So what are some of our biggest forecast challenges specific to the Central High Plains region? Well, with regard to aviation operations, like most of our other public operations, we're probably most concerned about thunderstorms and the lightning, turbulence, wind shear, and potentially severe weather that can accompany them. Low visibilities and low ceilings, either created by clouds or other obscuring weather phenomena like rain, snow, or blowing dust, are probably a close second. And most commonly, we have wind either in the form of strong gusts, changing wind directions, or wind shear associated with nighttime inversions, or the passage of fronts. This map shows all of the different National Weather Service forecast areas across the United States. And along with the TAFs, each forecast office produces an aviation forecast discussion. Those forecast discussions are semi-technical text-based products used to explain the scientific rationale behind a forecast. It offers background details on what to expect, why certain impacts are expected, and highlights points of uncertainty and possible aviation hazards that may not be explicitly mentioned in the terminal forecast. Every one of our offices is set up to provide backup services for other offices. And our primary backup office is Dodge City, and our secondary backup office is Pueblo. That means as far as aviation responsibilities go, we have the capability to issue aviation forecast discussions and terminal forecasts for each one of our backup offices. And in the case of Dodge City, which is our primary backup, we could be issuing TAFs for Dodge City, Garden City, Hayes, and Liberal. And if we were backing up Pueblo, our TAF responsibilities would include Alamosa, Colorado Springs, and Pueblo. Finally, here are a few of the aviation links you can use to get more information on any of the topics covered in this presentation. And that concludes the information I wanted to share in this presentation. For a review, we gave a brief overview of how the FAA and Next Gen and National Weather Service Weather Ready Nation initiatives are changing the way we produce and share weather information, including aviation weather and the information there. I described the 5 National Weather Service aviation operational units and how they were all part of the National Weather Service and some of the activities they did. A little more time was spent on providing some of the details of our aviation-related activities here at Goodland. And a few links were given where you can find more information about the National Weather Service and our aviation-related activities. We hope you enjoyed this presentation, and you'll join us for the next Facebook Live Winter Web Series event on weather and the agriculture industry. If you miss any of the Facebook Live presentations, they'll be recorded and posted on our Facebook, Twitter, and YouTube channels. And with that, we'll go ahead and open things up for any questions that you may all have.